Hi, my name is Brian Beach. I'm an engineer at Backblaze, and today I'm going to do a quick overview of Reed-Solomon erasure coding, which is one of the key technologies we use in our data center and our new Backblaze Vault architecture to store all of your files safely and keep them safe and available. So when we store files in the data center, we break them up into multiple pieces and store them across many servers so that if one of the servers needs to go down for maintenance, we can still retrieve all the files and have them fully available. In the Backblaze Vault architecture, we store files broken into 20 pieces. 17 of them are the original data, and 3 of them are what we call parity, that can be used to recalculate the file if some of the pieces are missing. When I go through these examples, I'm going to be using 4 data shards and 2 parity just because it's easier to draw. So the question is, if you take a file and you want to store it in the data center in multiple pieces, how do you break it up so you can recalculate it from some of the pieces? So basically, in this example, I've got a file. It's the letters A through P. I'm going to break it up into 4 pieces, 4 letters each file, and then calculate 2 parity shards that can be used to recalculate the original file. And the way that happens is through the magic of math. We take what we call an encoding matrix and multiply it by the original data to come up with the original data plus the parity that we're going to store. If you look at the matrix on the left, which is the encoding matrix, and you remember some of your matrix algebra, you can see that the top part of the matrix is what's called an identity matrix. It's got 1s down the diagonal and 0s in the rest of the matrix. So when you multiply it by your original data, you get your original data. Now this is good computationally because it means you don't have to do anything. That part of the answer is already calculated. The bottom 2 rows of the encoding matrix, though, and of the matrix on the right, which is the data we're going to store, is the parity, and that actually takes some computation. You take the bottom 2 parity rows of the encoding matrix, multiply them by your data, and you get the parity shards you're going to store on the drives in the data center. So this picture shows, after that result happens, what's going to go on each of those servers. 4 original data, 2 parity. Now we have released open source, a Reed-Solomon erasure coding library that you can use in your own projects to do your own coding. This is the same library we use in the Backblaze Vault architecture. It's high performance and scales for massive amounts of storage. This example code shows how you can use it to create the parity for the example we had in those slides. You create a Reed-Solomon codec with 4 data shards and 2 parity shards, create some byte arrays with your data in it, and then call the encode method, which will take the original data and compute the parity. Now the next question is, if you have a couple servers down for maintenance, how do you get your data out of the system? You've got 2 of the original data shards and the 2 parity shards. How do you do the calculation to get them back? And if you look at the math, the matrix multiplication goes row by row, so each row of the encoding matrix corresponds to 1 row of the answer. If you've got 2 rows of the answer gone, those are the things you stored on the disks, you take out the same 2 rows of the encoding matrix, and you still have a valid matrix equation. Now, one of the cool things about the encoding matrix, it has the property that any 4 rows are an invertible matrix, which means that you can calculate an inverse matrix, multiply by that, and they cancel out basically. They produce the identity matrix. So you take the original equation, put the identity matrix on both sides of the equation and multiply. They cancel out. You still have a valid equation, and the parts that's circled shows how you get your data back from the pieces you have. You multiply that inverse matrix by the 4 pieces you have, the original data and the parity, and you have your full original file. This diagram shows an overview of how that all works. You've got the 2 servers in the data center with the 2 parts of your file. You've got the 2 parity shards. They come down to form the matrix, multiply by the inverse, and voila, you've got your original file. And here again, we have a code example using our open source library where you create a Reed-Solomon codec, take some byte arrays with the data. The middle 2 rows are missing because those are the 2 you couldn't read because those disks were powered down. Then you call the decode missing function, and it fills in the missing pieces. You've got your original file. So once again, Backblaze has used this Reed-Solomon library as one of the core pieces of technology in our Backblaze Vault architecture, and we decided to make it available to you to use in your own projects. So go out there and start programming and have fun.